All right. Let's get started. And this is the Young Professionals panel on IoT and the connected world we live in. And so I'll just talk a brief, some brief history about what IoT Young Professionals is, and then we can get started on the panel discussion. So we changed the name from Gold, which was basically graduates of last decade, to IoT Young Professionals. This name change happened like a couple of years back. And after that, we have been able to, show a big impact on IEEE and activities that we do. So, what young professionals mean is basically anyone who has graduated within the last 15 years, or you can actually opt it. So, anyone of you can actually be an IEEE, you can be part of IEEE young professionals in IEEE. And basically, we are trying to increase member awareness and engagement. So, what it means is, if someone says goal, we don't really understand what goal is, and we need to know what. IoT professionals, from the name itself, it's evident that it's a group of people who are trying to bring up new things and being in the early stage career development. And always you can opt in to be part of IoT professionals and mentor the new guys. So we have around 120,000 IoT young professionals worldwide, and within the US we have around 43,000. And we have like 6 regions within the US, so all the regions combined, we have a good presence in the US and also outside. So this is the stats we have from December 2015. And one of the major initiatives from IoT Young Professionals is we are trying to organize meetups and panel discussions and events at global conferences. So what we aim is basically have at least one event in all the regions. So we have 10 regions, so at the end of the year we should have come up with like 10 events. And these are some of the events that we had in 2015, or meetups that we had in 2015, where we were present at the web summit, which is not an IoT conference, but we just want the presence there, having a panel, a booth, or a meetup basically to tell what IoT Young Professionals is and attract members to join IoT. And then we had a meetup in Bitcoin in Region 10, N3XT, which is basically a global entrepreneurship program in Canada. And then we were there at the Southwest CES, IMS, which is basically microwave symposium conference, and things like that. So we have started, this is from 2015, and we are having, we already finished a few meetups in 2016. In San Jose, we had a meetup with the Industry Summit, and then next weekend is basically like the honor ceremony in New York. So we had a meetup there as well. And now we have a meetup panel basically in Atlanta. So we're trying to tell people that what IoT Young Professionals is, and tell and broadcast what we do and entice people into IoT. So the panel discussion for today is basically IoT, Internet of Things, and connected world we live in. And these are the panelists we have here: Dr. Sam Murugesh from Western University, Dr. Rajesh Subramanian from Siemens USA, and Dr. Margaret Loper from Georgia Tech, and Jeff Evans from. And my name is Ramesh. I will be moderating this panel. And so what we would start off with is each of the panelists would basically introduce themselves, tell what they're working in, how they're involved with Internet of Things, and why they feel that Internet of Things is the next kind of the next big thing. So let's start with Dr. Sam. Okay, we can take it on.
Thank you. Thank you for the introduction. My name is Sam Murugesh. I am the editor-in-chief of one of the computer societies magazine called IT Professional. And my interest in IoT, started about 2 years ago. And I have been researching on that. And I am practically more application-oriented work I'm doing it. And I also conduct training programs on IoT as a corporate trainer. And so basically that gives a brief overview of that. And also my interest finds a number of areas, including cloud computing and Internet of Things and green computing. I recently published an encyclopedia of cloud computing, which has been published by both IEEE Society Prize as well as the Wiley. And more we'll discuss about this as we go on.
So I'm Jeff Evans. I'm the director for the Information and Communications Lab at the Georgia Tech Research Institute, and also the chairman of the board of a center that we developed at Georgia Tech that we call the Center for Development Applications of the Internet of Things Technologies. So my research background is mobile networks and how you stress for interoperability, et cetera. I find this incredibly important because IoT by itself is a marketing term. But the fact is that there will be these devices, they will interconnect in various ways. And so how you can leverage that information, how you get identity privilege management to get to the information, and then what are the big data components once you do that. Those are some of the areas that are focused on among our today CDAIT, our center there at Georgia Tech.
Hi, my name is Margaret Loper, and I am the chief scientist for the Information and Communications Laboratory at GTRI. So I work for Jeff as his lab chief scientist. So my background is really in parallel and distributed systems, specifically working in temporal synchronization of simulations. And I got interested in IoT, I don't know, maybe about 3 or 4 years ago, and there started to be this emergence of articles talking about, connection of things. And so I started to kind of see the parallel in terms of some of my previous work in parallel distributed systems. And so most recently what I've been doing is some research that's internally funded by GTRI on machine-to-machine trust. So the idea that when there are billions of sensors and devices that are connected in cities or in the world, we are going to have to delegate some amount of decision-making to certain of these machines. And so in that situation, we want these machines, some of these machines are going to have to learn how to trust each other and the data that they receive from other sensors and devices. And so that kind of general area of machine-to-machine trust has taken us into some emerging collaboration with the city of Atlanta on some of their smart city initiatives. So we're kind of pushing in that direction.
Good afternoon, everybody. My name is Rajesh Subramanian, and I'm with Siemens USA on the West Coast as a director. In terms of ComSec, I've been an organizer for many years, so this is home ground for me. Topics-wise, I have 2 major areas of interest. So in the last 10-15 years, my focus has been on all areas of software engineering, including testing and systems engineering. Where IoT comes in is from prior to that, my work, especially in the PhD research, was in coming up with how to gather data from what now is cloud computing, analyze it in a scalable fashion. And so I was into my knee-deep into trying to get those data, communicate it, analyze it, all of that. So I look at IoT with a lot of excitement because a lot of the fundamentals I had to deal with at that stage. So I was very happy to get the invitation to give me a chance to continue pursuing some of my old passions.
All right, thank you so much for the introduction. So I guess we have a diverse panel who can talk on various topics, and we have a list of questions which we prepared, and I guess it covers most of the part of IoT, and then we could take questions. So basically, we would be asking questions. The panelists would be telling their opinions, their suggestions, or what they feel about the things present in IoT, and then we would go forward. So to start off with, one of the questions that I've heard many times is basically, should we connect all the things? Like, do we need to connect everything in this planet together, or is there specifically some things which we should not connect? So, what is your opinion on things that we should not connect and things that we should connect? Anyone can start. So.
Okay, let me start. Technically, as many of us know, anything could be connected because as long as it has the communication capability and then has some sort of data sensing capability or some sort of actuation capability, anything could be made and then connected to the internet. So the answer would be that whether anything can be connected, yes, anything can be connected. But if it comes to the question, should we connect to everything? But the answer is no. Unless there is some value in connecting things, there is no point in connecting things there. So basically, it looks at it, what is the value we can get it by connecting to the internet? Because you can see that some of these strange things are happening in the real world. You get many new products that says that claims that they are connected to the internet, but I see is that it is all ridiculous. So I came across an ad and also a brief description about a toilet which is connected to the internet. Then it claims that you can flush the toilet remotely. To me, it doesn't make any sense. Yes, you can connect anything to the internet nowadays, but it doesn't make any sense. And similarly, there are things like egg miner. It is available commercially. It is all connected to the internet, but what it does is that it senses how many eggs are there in an egg tray, and then you can remotely access it from your office, that whether you need to buy an egg and then goes on. So when I look at it that way, there are many applications wherein you can connect it, but doesn't give much value. And also there are applications by connecting to the internet that increases the risk or it gives rise to additional risk. So one has to look at that, what is the value you get, and then the risks involved, and then you need to balance it. And then if it is on balance, if it is of value, then I should, why not connect it? That's my point of view.
And I tend to agree. I mean, it's a lot will not necessarily have value directed at us. The question, and we still don't have this understood very well, is the idea and the fact that 99.99% of the sensors that's sharing information out there, there will be out there in various ways, we don't need to know that information. But that's not so much the point, because there will be many closed loop. Most systems out there are going to be closed loop type architectures that will be collecting information, industrial issues, for example. And it's how we assess that, how we can turn that into metadata type information that can be used or extrapolated for our use. That's really one of the keys, and I don't think anyone yet understands just what that means to actually do that.
So yeah, I don't have too much more to offer. I'll just say that I recently did a report on trusting smart cities and looking at kind of the vulnerabilities of what cities are about to open themselves up to by deploying IoT technology everywhere. And so some of the things that I came across in terms of, experts, security experts talking in this field, a lot of it had to do with really thinking about what is doing a risk analysis, right? So just because we can connect a nuclear power plant to everything else, and make it available, what is the purpose of doing that, right? And you have to you may gain some value, but you actually need to look at the risk associated with doing that, and then do it and make those decisions. Cities need to make those decisions in a judicious way.
I think on this question, it's going to be a 4-0 for no. And so, I look at what are the criteria for it to be connected and what are the criteria for it not. The for and the against. So for is there has to be an economic sense or improve productivity or improve comfort, quality of life. Has to be one of those to make it a yes. And balance it against no. If there is a known safety, security, privacy, human rights issue, then you want it to be a no. To Margaret's answer, no, we don't want to put the nuclear plant online and pass it on to friendly and not so friendly countries.
All right. So the consensus is like we should not connect everything, and we should, look at the logic behind it.
Yes.
All right. Thanks. So let's start from Dr. Rajesh now. So how can we gain value from internet? How do we make it smarter and kind of gain the best out of it.
So I'm going to leverage back into the my previous criteria, and so it's got to do one of the following. So I'm repeating here, but I think it's valid. It's got to either improve productivity, comfort, quality of life, or economic. I think that was the guiding principle behind making the drive for IoT. The analogy I look at it is like, for example, we have test automation where you don't want to do something manually, then you can automate it. One can think of the IoT in a similar fashion. You want something instead of the human having to do it, be it in smart city or the traffic control, rather than going through that experience. You want the data to reach you to make your life better. So, that's an analogy of what exists versus where we are going. And we are really, in IoT, we are relying on the devices to take out our manual effort. Where manual needs to stay, it needs to stay.
And so I would agree. I don't think I have anything more to add to that.
Well, I would add there are many different ways that we are going to benefit, and we're still not really completely sure how that's going to happen. But let's just take an example. One of the test beds that we're actually working towards around the Georgia Tech campus, as well as the city of Atlanta, includes a host of various environmental types of sensors. So the correlation now that you can choose and do is to start to correlate that with health data that's actually being collected in real time, often by the individuals or by individual devices that the person has. So now can you correlate the environmental data of the city for that given time with the health of the person? So if you have asthma issues, can you then determine how the city can better respond? That's just one aspect. We also have some other things going on around public safety, with the ultimate being, how do you start to tie these different types of information that may be completely seeming disparate information? How do you tie that in so that you make a more resilient community? So we're talking about a lot of efficiencies, and that is probably going to be the biggest issue around IoT, but there are a lot of consumer benefits we don't quite realize yet.
Echoing on the points discussed now, if you look at it, what IoT can do, and then so that once you know what IoT can do, then you can realize that how you can bring value from it. I see it, basically IoT can do the following, one of the following four things, or all of the following four things. So basically it can monitor it, and then you can monitor it remotely. So there may be cases wherein, say currently you are not able to monitor it, but that IoT provides that facility. Or you can also monitor it, control it, you can remotely control it, or you can automate it. And then you can also, one step further, as Mr. Rajesh said, then you can optimize it, optimize the performance, optimize the functions, and personalize things. And then you can also provide the ability to collaborate one another, because you don't get the value just connecting by one object or one thing to the internet, but you gain more value if all the related objects or the things connected together, and then they collaborate and coordinate with us, that's where you get a higher value. So probably that way one can look at that, how one can get a value or benefit from IoT, not just only connecting it, but also collaborating it, and also seeing that what can be done autonomously, what can be optimized, knowing that there are other information which are not available earlier, now which are available to you.
Thank you so much. So one of the issues that we are always hearing is basically data breach and privacy issues within IoT. So how do we make sure that IoT applications or IoT devices are reliable and secure, and how can we create trust among the people who use IoT?
I'll just make a couple of comments. It's absolutely amazing that you see people who don't want to share that type of information, and yet they do. So they want all the information to the point where Symantec, I think it was, called it the quantifiable self. How do we quantify ourselves? And that's what a lot of people want to do, but then when certain information and data breaches happen, they get frustrated. But the point there is that these will happen. One thing that we're trying to do is, can you develop a, rather than doing point solutions, a lot of times security is settled for in vertical markets. So we've done some work with the TIA, the Telecommunications Industry Association, to look at the standards around what's called smart devices. Can you develop, in a sense, a broad, secure profile for these various devices? There are some very basic standards. They're not there yet. Right now, the solution is to find when somebody makes the hack, such as with Fitbits. If you might remember, some of the first Fitbits were quite easy to hack, and now that has changed. But even there, with the Fitbit, there's still information that's being derived that people don't really understand. So one thing we're looking at is if you have information from your Fitbit that says that you're in a certain location at a certain altitude. So then somebody can say, hey, I know they're working on the 5th floor of this building. We know that type of work is being done on the 5th floor, so this person is now involved. There's all types of information when we talk about security. It's not just hacking the device, but it's deriving the information.
So here I see two areas. One is in terms of just the privacy laws by itself, because IoT is moving very fast. I would like to see the standards and consortiums to look into what should be the rules for privacy and try to come up with some basic guidelines. The second is in terms of the disincentive. Should it happen, who is to take the liability? What prevents us from hitting each other as motorists on the road is we all know what will happen to our insurance. So there is that disincentive or an incentive that helps keep us in check. Now, in the case of the IoT, if the liability laws are clearly understood, because you have small devices coming from different manufacturers, etc., that will help. It's not going to help prevent, but at least a step in the right direction. So I would like to see these two things occur. Some consensus towards strengthening a common understanding of privacy. So it's not like the devices are gathering data and selling data, and the Wild West. And two is in terms of liability. So it'll kind of bring some. It'll sober down the security.
So I'll add to that. The one thing I've learned is we've been working with the City of Atlanta in their smart city initiatives is that when asked about the privacy, kind of what are they going to do with the data, right? There is a question that's a question that's not answered for them yet, right? They know that they want to deploy sensors in the City of Atlanta. They believe there is value to having this data and to having data that is actionable to help the citizens of the city. But they recognize that there is this, fine line, right, between collecting everything just because they can and the transparency of telling the citizens what they are collecting and what they're going to do with the data. And so that is one of the areas, for example, I was talking to somebody just recently from the city about this, and their comment was, we, in the right of ways and main thoroughfares in Atlanta, we have the right to collect data. It's part of, I guess, city policy, city governance. But they also have a responsibility to tell the citizens what they're going to do with that data, right? So there's that transparency aspect of we're going to collect it, and this is why we're going to collect it and how we're going to make that actionable. So I think one of the things that from a Georgia Tech perspective, research perspective, that people are doing is we actually part of deploying smart city test beds is actually having the companion projects where it's not simply about the technology, but it's about having the social scientists on the ground talking to the citizens and the communities that these sensors are going to be part of, and trying to get them engaged to what we're doing, why we're doing it, how it could be beneficial to them, how they might use this data to improve their lives, to actually get buy-in from the beginning, and not to feel like, when sensors go up, it's Big Brother, just all of a sudden, watching them kind of thing. So I think that, it's it's a hard, very hard question. And I think that, everything from legal to citizen engagement to technology that filters out, things that are personally identifiable, it's a multifaceted problem that, will require, multidimensional solutions.
Apart from the data breach and then related privacy issues, another issue which is also equally important or more, say, concern is that issue of security. The reason is that many of the devices, particularly the sensors that are commercially available now, though they are internet ready, but they lack security. It's not secure, so that becomes the most vulnerable point in the whole network. And then there is a need to improve security, and then there comes the problem. Because many of the security techniques that has been developed is meant for the large-scale systems, meaning that the computers and other things which have large computational power. But when you talk about the node, like sensor node, that has only very limited computing power or computing resources. So what we need is that security measures or solutions that are lightweight, so that even from the node perspective or from the node point, that it can be secured. Because there have been recently some cases wherein people have tapped that vulnerability right at the sensor point, and simply hijack the sensors and then completely mask the application. You might have heard of some applications, say the so-called autonomous cars, or your privacy locks in the houses and things like that. It could be really, say, hijacked, and then it can lead to many disastrous consequences. So one has to look at the security aspect as well, besides the issue of the data breach and then the privacy issues involved. So this is an area which is of a major concern, but we don't have really many solutions to that. Obviously, it is an area of research as well.
So the takeaway here is that we don't have really a solution, but for bringing trust to the people, we should be transparent with them, and we should bring some standardization process to make sure how we could go forward, in continuous data breach.
If I can just add, we could use examples, simple examples. For example, we have our smartphone, we have a password to enter, and for certain things such as location finder, there is a prompt, and unless you accept it, it doesn't switch on. So we could kind of take those simple things as steps and then move. And to Sam's point, I mean, the devices are so small and they can do anything. So there has to be some basic to start with. You just don't let it out and then think about it.
Okay. But one concern that we have is like, do all the companies or do all the devices tell the people that we are taking this much data, or is it kind of hidden? Or, I mean, is there a rule? Or I don't know how it is. I mean, we should be tracked and that's how it should work, but is that happening?
I don't think so. That's why I said that should be a liability on the manufacturer.
Okay.
So then you have a check and balance straight away. You can manufacture and you can sell it. If something goes wrong, if you're going to get sued, then you're going to think about what you're selling before selling.
Yeah, and the last addition, I'll just use one basic example. Many of you may have heard of Nest, and that was the in-home smartphone type platform. And I guarantee you, Google, this doesn't necessarily mean they're bad for doing this, but Google did not pay $3.2 billion simply to be able to help you control your HVAC in the home. They did it because there is a set of information that they can derive that helps them market you better, that helps sell better, that provides, in their minds, provides you better service. So I guess that's part of the distinction too, is some of the policies between what's providing better service versus what is actually violating someone's privacy.
Thank you. So nowadays we are hearing that few universities are actually starting to provide IoT academic degrees, like a PS or MS degree. And do you think that really these degrees are really of professional manner? Is a PS in IoT technology or a MS in IoT technology really that valuable like a PS or MS in computer engineering? Because the electrical engineering is like a super set of all these things that we actually do. So do you think really we should, have a BS or an MS in IoT academic degrees, and how do we tie this up with professional education?
Yeah, so I can't talk, authoritatively about all universities and how they're approaching education. But I mean, there are universities abroad that are offering IoT degrees. My guess is that countries where they have declared IoT as a national strategic priority are countries where you see degrees that are coming out of the universities, right, to meet the nation's strategic priority in terms of this technology area. I would tend to agree with you that I think that, there are traditional degrees that you can get where you can get all the same courses, in the US, and so you don't necessarily need to have a degree that's specifically stamped IoT. That would just be my interpretation. But I do think that there is a really big opportunity for professional education in this space. And so that's an area that I've worked, not just starting to get into the IoT professional education, but I've worked for a decade in professional education for modeling and simulation. So I have some general understanding of that form of education. And there really will be, for folks who have been in the workplace for a long time and are trying to transition into new career opportunities, for companies that are starting to get into, providing IoT services or IoT types of technology, new systems, right? They have, they need a workforce that is more current with what's going on in this technology space. And there are a number of different, if you Google IoT education, professional education, I have anybody who's interested in this, just send me email. I have a whole list of different professional education courses. Some are offered by universities, some are offered by companies that are more focused on their product or software, development environment, that type of thing. I think what we're going to find in one of the areas, Jeff mentioned the IoT center that we have at Georgia Tech called today. I'm co-chairing a working group on IoT education with that through that center. And one of the things that we started to realize is that, or one of the way that we're tackling the professional education is to try to understand what are the roles in IoT, both from decision maker influencer perspective as well as the engineer implementer perspective, and then what are the types of skills, IoT skills, that are needed for both of those general types of IoT roles, right? And so it's not that anybody will have the IoT education, but if we can hope to create, a type of directory or catalog and make available to people to say, if you're interested in learning about this type of sensor or how to connect to Watson for this type of analytics, here's a course you could go take, right? Not any, it's validated in any way. It's just a service of what types of professional education are out there, because I think it will be needed, as we start to move along. And I think that it will, I'll just add one thing, I think that is going to be critically important when we start thinking about deploying IoT technology in cities and public infrastructure, because we have, the people that are working in those state and city governments, right, are going to be in great need of education for this, because they have a great responsibility in terms of the vulnerability that this technology presents. So that is actually a really big area, because, right, cities are going to have a terribly hard time competing with commercial industry for, for these tech savvy folks, right? So this will be another area where IoT education will be very valuable.
I have a slightly different viewpoint, but if you look at the undergraduate program or a postgraduate program, particularly undergraduate program on IoT, I see that it's more of a packaging and then making use of the buzz that is there. Because if you look at IoT, it is not just by alone as a standalone technology, it's only an evolution. So most of the fundamentals what we use is still applicable there. So it is only kind of same. What we apply is different. So I would say that the degree, undergraduate degree in IoT is only the packaging because the same fundamentals apply that has to be learned. But in the postgraduate, yes, probably you could specialize it. Because once you learn the fundamentals, then you can apply in the IoT context. Then there are issues involved in terms of scale, scalability, flexibility, and other things. But yes, by all means, a professional education for those who have already gone through the education, formal education, the new thing, IoT, and then new dimensions and analytics, and how do you manage the data that comes from the large volume of data that IoT collects, and that is good.
I'm a bit opinionated on this. I have my strong opinions, having served both on the academic side and the industry side. So what I feel is from a education at the university level, you don't need a degree in IoT, and for some of the reasons I mentioned. What you need is your basic hardware plus software plus systems plus networking. And so that by the time you finish 4 years, if the name IoT has changed to something else, you don't have to go back to school and get 4 years more of degree. Fundamentals are fundamentals. At the master's level, you still don't need. You could have an elective in order to get ahead on your resume and have the packaging that you need at your undergrad level, at your master's level. Should you decide to do a PhD and you need a research topic, you need something narrow and focused, and that might fall into IoT, and you may still have IoT in the title of your PhD thesis. Of course, by the time you finish your PhD, they will call it something else. But I went through that. I changed the title 3 times, and the fifth name is cloud computing. So now I just use the word cloud computing, and I'm from the previous generation on that. Now, the other aspect of it is from a technical institute where you have those hands-on people who are skilled. There, it definitely makes sense because they're not learning a fundamental knowledge to apply. They're learning the hands-on skills right away. So you could have an IoT program to help with certain kind of sensors. They know, they learn, and 3 years later, if they need to go through retraining, that's fine. So on the first one, no, because both it's not going to help the person involved, and from an industry perspective, then we would have to be retraining them every 3 years, every 4 years. So when ubiquitous computing was a thing, you could through, etc. So hence, I have my opinions there, and for the same reason. So the smartphones have been for the last few years. You don't get a degree in smartphones. Wireless phones have been there for 10, 12 years. You don't have a degree of wireless, so you don't need it for IoT.
So the consensus here is like, we should have a bachelor's or something in computer engineering, electrical engineering, make a fundamentals right, and then go forward for a research aspect on IoT, whatever it may be in the near future. So we talked about the gain, how we gain Internet of Things, how we gain the value from Internet of Things, and we also talked about the data breach and the other security issues that we have. But apart from this, apart from this data breach or data security issues, do we have any other key challenge, in realizing Internet of Things, or taking out the potential of Internet of Things? Apart from data breach, can we think about something else that is, as threatening as data breach, but people are not still aware of it, and you could see it as a potential issue that could, really target our transformation to Internet of Things?
So one thing that, so yes, I think that there's still are challenges. I think the vulnerability, security issues are huge. But another one that I think is equally important is the scale of these systems, right? These are going to be unprecedented systems to be billions of devices that are connected, right? Anybody who's taken a class in complexity theory or done any agent-based modeling or anything, right? It's that whole emergent behavior when we get these systems connected, as standalone systems that provide some type of service in a city, for example, that's great when you connect it to something else. It's just, you kind of can get to normal accident theory, right? Where all of a sudden, the best of intentions and the best of the technologists bringing it together, and that things happen. So I think from the scale perspective, I don't think that we truly understand, what the complexity of what we're moving into. So that would be an issue. And I do think that there are another great challenge is kind of going back to the smart city is vendors, companies develop, their software developed systems that do extremely good things, but it's designed to be an ecosystem of their products, right? And so that whole interoperability of these different types of systems that provide different functions and provide different value for whatever ecosystem they're designed for, I think it's going to also be a great challenge. And it's going to especially be a great challenge in environments where you can expect that the workforce, have masters and PhD in any technical field, right? I recently heard someone from DOT speak, from Department of Transportation, and they were talking about V2V, intelligent vehicles. And one of the comments that he made was that the whole idea of V2V scares him. And the reason is because when you look at the people that work for DOT traditionally, the skill set that they recruit and hire are not technologists, right? It is folks that understand roads and geography and the structures and stuff, but not the technology piece. So when you all of a sudden put them in charge of that technology, they don't have the person power that is educated for this. And so just to deploy the technology and put them in charge of it, to him was very scary. So I think that that's another great challenge, right? It's not a technical challenge. It's going to be a human challenge.
One of the challenges, basically, as she mentioned, is the compatibility and the integration issues. Because now what we have is the proprietary systems. And then it is not easily compatible with one another. So that's also one of the main reasons that is preventing the, say, wider application of IoT. Standards started to emerge and the industry groups have started working on it. We need to see that how far it goes, and then when it get a globally accepted and commonly accepted interfaces, and then so that the device, you can get the device from anyone and say any manufacturer, and then get them together and then get it operating. So that I see as a major issue. That is realized by many, both by the users as well as the industries, and they are working on coming up with some common standards so that we can connect devices from anyone and everything, so that we get a hub that is much more, say, viable and also much more economical than going for a proprietary system. And as you mentioned, the thing is that we are going into a bigger scale systems, or what you call as a mega systems, a system of systems, which we don't know how the failure in one aspect or one node affects the overall. So as we go into the major systems like smart cities, where many sensors are connected, so the failures, the impact of the failures, and how we model and simulate it, we don't have still a mechanism or an approach to address that. So probably besides the security, privacy, and managing the data, and these are the other issues. I think that is of concern and that need to be addressed. And of course, that also opens up an area for research and development.
So, Ramesh, your question was of concerns beyond security. So I look at two areas which I would say definite concern, bordering scare. So let me just call it as concern. One is in terms of the whole data pollution. The volume of data that you can create is huge, and because of our networking and wireless capabilities, we seem to have forgotten. So it's kind of like in the early days of industrialization, where we thought we could pollute everything. So we are at that stage of the curve. So unless we have a situation where we bring the network down or we just flood the whole system, we're probably not going to think about it. And then in crisis, we'll start to think about it. The second is the lack of human presence in decision making. The other way of looking at it is what Stan pointed out, when you have them connected into decision making, you could bring down the whole city. You might be very smart with a smart city on the happy path, but on the unhappy path, it could be a very unhappy path. So the bottom line for these two concerns and everything else, while I look at the technology or the usage of it, it's more an application than the technology. It's tremendously important. With low cost, we can achieve so many things. It's a little bit of a toy in the hands of a kid. And I think all of us have a technical passion and we are running wild with it. So somewhere we need to stop back and think.
Yeah, so if I could add, I mean, it's echoing some of this. To me, this is the ultimate system of systems. But there are still a number of research components to it that we just don't understand. And it fits sort of my background, especially on the wireless mobility side. But you've heard so many stories. You may remember that for many years, the carriers, the AT&Ts and Verizons of the world would not offload their data to, for example, a Starbucks for Wi-Fi. Then they realized that even on 3G systems, the volume of data they were having to deal with was overwhelming. So they immediately, that became their friend, being able to offload locally on Wi-Fi. We're only on the cusp of what something like that's going to be. So there's already a dozen different wireless protocols out there. There's not sufficient spectrum. So we've got to come up with techniques around how do you create a dynamic spectrum access? How do you create the awareness so that you understand multiple protocols? Tremendous amount of research that is going on there. And I think that that's actually where one of the ultimate is going to be. Can you start to offload? We mentioned Department of Transportation, and we worked at Georgia Tech. We worked on some technologies around 5.9 gigahertz about 15 years ago. The federal government is just now bringing that to the table now and says, okay, we're going to now make it at 5.9 gigahertz, 70 megahertz of bandwidth available, and all cars starting in 2017 must have this built in. We can imagine this technology was done so long ago, 70 megahertz of bandwidth. Now you put a few thousand cars, a few street blocks, and what that's going to do to the communications capabilities. It's not really going to be sufficient. So we've got to find smart ways to offload that. And I could go on, I could do whole presentations on this. So this is, to me, a very critical issue if we're really going to make the system of systems interoperate.
Okay, so I guess data fusion, scalability, and other issues are there apart from data security. So there are pretty big concerns right now. Okay, I heard many of you speak on smart cities. So how do we use IoT to leverage the connectivity that we have now and enable smart cities across the world? So do you think that is possible, or can we have a better connection between the US and the China, or kind of connection as a smart city, or is it like out of the way?
Technically, yes. Politically, question mark.
I agree. There's a lot of programs going on where we have sister cities, if you will, and we're sharing information about how it works. But I'm not sure that we're anywhere close. We're probably many, many years away from being able to develop something, the synergies that you would share if you could actually tie them together on global. What you can see is maybe cities in a regional area that might tie together for better power management, better transportation control, et cetera. I don't see the compelling capabilities even exist at the moment to other than just sharing best practices to do that globally.
All right, so I'll have one more question and then we'll open up for the audience. And so it's like we talked a lot of IoT. What are the issues that we have? What is the current state of technology that we have? So what do we expect IoT to do in the next 5 years? What are the advances that you are thinking on IoT, and how do we enable ourselves or make us capable of coming up with changes to that to the changes that IoT is bringing to us? So a person who is not capable of sharing information, say a smart city comes, and he has to share information. So how do we make people aware of it, and what are the things that could happen in the next 5 to 10 years in the areas of IoT?
I'll go with the second, because I think as far as the awareness is concerned, people, and I'm not talking about the region, but globally are very much aware of the trends. We didn't really have to sit down and tell them about smartphone. Everybody got it. So the 5 to 10 years, I see it more in terms of the focus on IoT will be more and more on the applications. What can I do with the data? So it's the same thing as what we have in the smartphone. We have the technology, we have the hardware, we have the software, then it becomes all about the apps. So I think that it's going to follow the same trend, the difference being the smartphones are 5 years ahead of the rest of the IoT. So it's going to be what can we do with the data, and what are the where can we put the sensors, what data can be collected, what can we do with the data.
Yeah, so I would agree. I think that people will engage more, and when they see that it makes their life easier, right? If there's something that some service, some app that somehow makes something easier for them, that's how it's going to gain traction. Georgia Tech is actually part of the NEST Global City Teams Challenge Smart City Initiative. Some of you might have heard of that. So it is an initiative that NEST started right after the White House announced its Smart City initiative. And what's been interesting about participating, it's cities collaborating with their local universities or companies to do smart city projects. And one of the things that's been surprising or interesting about being part of this is the sheer number of projects, right? So this just started in the fall. Next week in Austin, if any of you happen to be there, there's a Smart City Expo that's happening. 90 projects are being presented from cities and their company university partners. And it's quite a range from transportation to public safety. There's smart buildings, there's health and medical and health applications. And so a lot of it, our particular project happens to be this test bed that we're creating with the cities. Ours is much more infrastructure security focused. But I would say 99% of the projects are app related. And so to second this, I think that when these apps and these services roll out to cities, if it is to improve their transportation options, if it is to help them in some personal safety perspective, traversing the city, if it is making them aware of flooding in a particular area that they travel or live. Once these things start to roll out, people will start to realize that this technology is going to help their lives. It's going to make it better, and then it'll just start to gain traction and from there.
Actually, I think that in the next, say, 5 to 10 years, the advances will be in a few different directions. On one side, the sensors and actuators that we want to connect to the internet, that will improve in performance, and also it will be more reliable than what we are now. Because a lot of industries are seeing a value in being in the IoT market. They are working on it. And as a result, and more applications are going to use the sensors and other devices, the cost will come down. So it will create some sort of a positive spiral. So the more and more devices will be connected, or more and more things would become more IoT enabled. On the other side, there will also be new standards will emerge. The issue of compatibility to some extent will be minimized, or the issue will be addressed too, because there are many industry group consortiums are working on it. So we would like to see, like, you can connect a sensor from A, from B, and then we'll be able to connect it in the years to come. But apart from the smart cities, I see a lot of application in the area of IoT or in the industry, in the area of logistics, in the area of retail, and other things will emerge. So already there is a large number of companies are working on what you call as the industrial IoT, basically IoT application industry, which some people call it as Industry 4.0 or 4.0. And similarly, the healthcare applications as well. So the application domain will become much larger, both the industry, healthcare, and home appliances and other things. And also, we will see a lightweight solutions, both in terms of the analytics as in terms of the security solutions. Then we will see a lightweight solutions, because our end devices are all smaller devices, low-cost devices. So we need to have solutions that are also likely to emerge. And one of the barriers that limits the IoT applications is that in the case of battery-operated devices, the battery power consumption is increasing. So the battery capacity will also increase, but at the same time, techniques will be developed to reduce the power consumption of those end devices. So I see that there will be development in many few different directions, and at the higher level, the so-called the concept of edge computing and the fog computing also will become more prevalent, so that the data collected will be stored on the cloud through the various say layers passing through. And one of the problem currently is that putting the IoT into real-time applications is the issue of latency. The time delay between the sensing and transmitting the data to the different resource for storage and computation getting it back. So for that, the techniques called the edge computing and fog computing is being addressed too. I think that also will be emerge much more say viable manner than what is currently proposed. So I see that a lot of developments in the very few directions, and also applications will increase.
Yeah. So just to echo on that, with the fog and the type, I do see whether we've expressed some concerns about having the decision making being pushed down to the devices. That's what's going to happen. The devices are going to become more, if you will, cognitive, more aware that they at least have some limited decision sets, and then nearby will be various gateway devices. That's the architecture that's evolving for either your personal area network that you have. Right now it's your phone, but what does that look like 5 to 10 years from now? Same thing in the home, there will be various gateway devices. So you're going to be pushing the cognitive functions as close down to the individual sensors as possible, and that's one key. And also agree that I think apps will be important. We don't know what those, the $1 million app will be, but I have to share one quick story. One I was always fascinated by when in Kenya, when they first started coming out with 2G, 3G phones, one of the first things that was developed was something called M-Pesa. You may have heard of that, this ability to do microfinance. So suddenly the people who had no access to capital, suddenly were able to do microfinancing on $5, basically, just a few dollars at a time. And they have stations around the cities where you can top up your M-Pesa. So that was something that was done because you had mobility, because you had phones, and even then were not necessarily smartphones, they are now. So what is an app such as that really starts to become a game changer for the person? That's what you're going to see in the next 5 to 10 years.
All right. So I'll ask one more question on the audience. So can we go out from this room, with the mind that IoT is the next big thing? Yes, no, maybe, not sure.
I don't know whether you call it a big thing or not, but it's something on an evolutionary path. So the scenario will be different from what we currently is. Whether we call it a big thing or not, it's only a matter of say, your judgment. So I think that but more and more devices will be connected, will be becoming more and more smarter in using those devices, and that is true. But whether it will have that much of, say, people are talking about many billions of devices will be connected and so many trillions of businesses will come. that all need to be seen.
Two different comments. One is we know we have the capability. What we don't understand fully is what is the need. You have to look at it the other way. What is the need that you're trying to fulfill, and take 5 steps back into, okay, that is the need. What's the technology that can do? What are the pros? What are the cons? Should we go ahead? Then let's assemble it together. So that's one half of the answer. Once we understand the true need of it, then I think there'll be a better answer to yours. But definitely, it is a game changer right now. Whether it'll be the same 5 to 10 years from now, we don't know. The second unrelated comment I want to make on this is how a certain, and I won't name the company, it's not the company I come from, but it's a US-based company, looked at such technologies. For them, and they're not the only one, they said that we will, throw the several hot area names, knowing fully well, and we'll invest on the R&D for it, knowing fully well that 1 in 5 might catch, but if the 1 in 5 catches, we don't want to be left out of the game. So what we all see as technologists is faster than we can keep pace. There are new emerging technologies, but if you start looking 2 years back, 3 years back, 7 years back, there are some technologies which were absolutely hard to never to fail, just didn't make it, and the reason doesn't have to be because of technology.
Yeah, I'll say that I think it will be a big area. I don't think it'll necessarily be the big area. And I'd say that only I look at Jeff because I look at at GTRI, our organization, and the research that we do. This is the IoT, directly IoT related research is a very, very small part of the whole portfolio of what GTRI invest in. So I think that, will there be lots of opportunities, lots of very interesting opportunities, lots of, possible good impact? Absolutely. And I think it will drive a lot. I'm just not necessarily convinced it is, the one and only, research area or technology area moving forward.
Yeah, it's kind of like I said at the beginning, IoT by itself is a marketing term. The point is, though, is that we are becoming increasingly connected. It's going to happen. There are many, many devices, tremendous amount of research, but whether we call it IoT or pervasive computing or ubiquitous access, even another term is cyber physical systems. So all of those terms just simply mean that there's somebody that is so easy now for us to share information that they're even building now sensors into your clothes. So, the wearables and that's for clothes, but also for the Google Glass. It didn't quite make it at first, but in a few years, something along those lines will start to take hold. And there's always a hype curve, the so-called S curve, where you have tremendous amounts of hype. But then you realize that you don't have the technical awareness, you don't have the driving real need for it or how to utilize it. So then you drop into something they call the trough of disillusionment. But invariably, if the technology is worthwhile and things keep moving forward, those do tend to come back. And you see that. So whatever we call IoT, it will happen.
All right. So do we have any questions from the audience?
Yeah, I have one question. One thing that you mentioned is reliability. And how many people be comfortable sitting in a state or turning the stove an hour before you go home to your dinner? Where does that fit in the whole picture? The reliability of these many devices. And I project the second last point where we are trying to push the decision back to the devices. How reliable is that? Okay, how much trust we as consumers will have in that? I don't know. Has there been any research on that? Has anything looking into it?
Yeah, so that is an area when when I introduced myself and said one of the areas I was currently working in is machine-to-machine trust. Reliability is part of that, right? I mean, when you think about the definition of trust. There's a number of subjective as well as objective criteria, right, that how you would describe trust. And reliability is one of those. So, you know, I wouldn't say that, at least from what I found from the 200 plus papers that I found in trust, that there's necessarily the one consensus that this is from a machine-to-machine perspective. There's far more research in the human-to-machine perspective. But I do think that that's part of it, right, is that we can't, there is the idea that when you're surrounded by all of these sensors and devices, there's the vulnerability of, is somebody maliciously trying to manipulate the system, but there is purely the just, did it fail? Was there just a failure, right? Did you know, and in that sense, there is that sense of how do you trust. I think the way that I think of trust in terms of the past year and a half of digging into it is that trust is at many levels, right? And there is, you know, from a hardware security perspective, there is the more computational between machines that are exchanging information, and there is how humans are going to trust these systems that are surrounding them and that they are delegating decision making to. And so I think that one of the areas that will be really important moving forward is having that comprehensive across layers perspective of trust in these systems that account for, you know, everything from just, you know, failure of systems to the malicious, you know, manipulation of the system. So yes, is there research? There is. I wouldn't say that from what I can tell, that I think that it is starting to become more of a tagline that you hear in the buzzwords of Internet of Things and products that are coming out. But from a research perspective, I would say that there's not as much that's published on pure, we're looking at, you know, we want to fund research in this area. That has actually been a struggle, because when you describe the problem to people, they say, you know, oh my gosh, yeah, that's a problem. But no, we're not funding that. So I think that we're just, as it starts to become more, you know, prevalent, you know, in terms of where the technology is going and how it will impact your life, I think that it will start to become more recognized as this, you know, all these dimensions of trust, security, and how that's going to impact us.
Yeah, I think one thing I just see a lot of talk about in which is the unintended consequences. I mean, yes, I don't know much there before I'll be there, so I was also by So I wish there would be more attention paid to not just how good these technologies and how we have our life to be in, but also we to be aware of these unintended consequences that we have, especially when it comes to impact on the property and human and so I think that's the part that personally that scares me. We're not getting that much attention to that piece. Because I said, it's IoT a marketing. It's a lot of people very profit driven, but probably that's the other most of this attention. That's a scary piece.
I agree with you, and perhaps in our Q&A we omitted adding that to the scary list. However, I see that two things can happen. There is a consumer, and the consumer is not going to use the IoT for the house or the car if he or she doesn't have that level of trust. So it's left to the marketing or the manufacturing company to address it. They may not address it today, but if they don't address it, they don't have a sale. Okay, so the law of economics is going to catch up. Two things will happen. One is that either it gets addressed, or two, we move on, and that area of technology or application remains untapped. So one of the two things have to happen. It has to be addressed. If it's not addressed, then we will not have self-driven cars, or we will not have set the house on temperature control where you can set up.
Exactly. Because we don't want to wait until the house catch fire to do this stuff. You
People don't buy it. They'll not buy that product.
Really inspiring panel conversation. I enjoyed the particular conversation about business benefits as viewed from different stakeholders on it. I was curious about something like this with international multicultural scale. Match up two examples I have probably read those throughout the meeting, and since we're having a sensitive conversation, it's very clear all cell phones have to go your refrigerator because they do a really good job listening. Similarly, our gauge or our daughter in Spain recently that turned out to be manufactured for the Chinese market, which of course is brought back to the US. And the question of each of these objects is listening to everything our daughter says on behalf of them, governments and countries, companies, etc. There are a lot of different risks and benefits from the child perspective, parent perspective, government perspective, the company perspective. Yet you wouldn't want to overregulate too early on because you don't know where all this is going. But do you have any thoughts as young professionals are hoping to develop global products and help them sort of think about how to craft the devices trajectory through that space?
Incredibly challenging. It's incredibly challenging, but that is, in fact, if we're all going to see the benefit, that's one of the key impacts. But and that's why I used the one example of the M-Pesa. And there's questions in terms of why that has not taken on more of a role around the continent. It's been in that general area. And there are many reasons as to why, and some of them are cultural. And that's something maybe, that's another thing that we don't really understand is how to design something that's in a culturally relevant way. We don't really focus on that as much. We're doing it for the given market. And while we say it's a global industry, it's still targeted markets. And a lot of that design's not there yet. So we've heard stories, I believe it was the Sony TVs that had the camera still turned on or something like that, or the audio was monitoring or something to that effect. And you can believe when they said, well, that was kind of built in as part of the test, but they weren't really monitoring anything. You can tend to believe that. But the fact that it was there is what's going to cause consumers to stop.
When you asked the question, my first inclination was to duck, not to answer. But then, as I thought through it, the key is to understand, and here IoT is not, I don't know how much of regulation is there, but for any regulation to understand what is that they are really looking for. And I'm in the regulated industry for the last 6 years, having come from outside. One of the things I first did was to try to understand, because our company could be shut down anytime if it doesn't clear the regulation, and we are regulated by FDA. So a regulatory agency, bottom line, is just looking at two things. What is that you say you do, and show what you say you do, you do. That's step number one. Two, if there is any deviation, then there is no risk to human safety. That's the bottom two things that they're looking for. So whatever technology as young professionals you're creating, should there be a regulatory? You can understand what they're looking for and provide it to them in the simplest of forms, then you get past that hurdle. Fortunately for us in the system, we have a professional organization that goes with what you can prove is taken in as advised. We're not in a situation where we have to go through through the human convincing act. It's based on the strength of what you have written down.
Thank you. Any more questions?
I'm curious on the example of the smart city that offer here. Give you some example of what the city are doing for this.
So, one existing service that I think that the city of Atlanta, I can't say accurately how widely deployed it is yet, but are these big belly trash cans. Has anybody ever heard of that? Okay, so it is Big Belly as a company, I believe, that's putting sensors on trash receptacles. And the idea is that instead of going out, and I'm not sure whether this is residential or commercial, but the idea is that you only send out trash trucks to pick up receptacles that are full, right? So if they're only partially full, they can wait for another route. And so from that perspective, they expect to provide better service because, they can be more responsive to those customers that, are maybe more frequently filling up, trash receptacles, that they can reduce costs by not sending out trucks to pick up, very sparsely, containers that don't have a lot of trash in it. So that so from their perspective, they're going to provide a better service to the citizens by being responsive to their needs and reducing the cost of, overall, trash pickup. So that would be one. Another one that just, as Friday, I was talking to somebody from the city, and one of the things that they were very interested to kind of pull on a comment that Jeff made about environmental sensors. One of the things that they said is that for those of you who have never been to Atlanta, if you're not from Atlanta, you know that we have, these really bad smog days or, pollution days where the overhead signs are, flash warning. If you've got, some kind of respiratory problem, you should probably just stay inside today. And so one of the things, the services that they want to be able to provide people is that they know the overall particulate count for the city as a whole, right? That they just have this gross value that just says for the city it's here, but they don't have actionable data that tells you what the particulate count is in any particular county or city, or suburb around town. And so when they have people that are moving, right, so Atlanta's fortunate, we have all of these, Fortune 500 companies moving headquarters, relocating headquarters here, and they have people that are saying, okay, someone in my family has some type of respiratory, illness. I need to know which part of town has the lowest, traditionally, consistently has the best air quality. And right now they can't tell anybody that, right? They don't have any way to have actionable data to help citizens really understand anything from mobility, health, things like that. So those would be at least some of the most recently discussed examples that I know the city of Atlanta is thinking about. And I guess the last one would be that's a very obvious one is they're doing an LED retrofit, which many cities are, right? Replacing the street lights with LED lights, right? So that they can be, more cost effective in terms of energy costs. So those are, some very maybe typical. I think a lot of cities are trying to look at this, at those types of services that they can provide citizens.
Yeah, in addition to the smart, what you might call a smart street light, there's they found that if you can turn off the street lights in certain areas because there are no people in the area at a given time at night, and therefore they can save as much as 30 or 35% of their power usage for that evening. So there's lots of things going on there. I know the city is working with AT&T and others on projects around how do you do smart water monitoring so that you can look for leak detection. So a lot of it's about making the city more efficient. And something that's evolving is that it's not quite there yet. We've done several projects, and that's around can you embed sensors now in infrastructure, bridges, and look for the vibration effects, not because necessarily the bridge is going to fall down. That's the ultimate catastrophe. But the real reason is, can you start to understand the maintenance requirements? Is it going to have to be repaired in 10 years, or is it going to have to be repaired in 20? So again, it's starting to make budgeting, efficiencies, et cetera. Those are a lot of the things that smart city is working towards.
All right, thank you. I think we are out of time, and I think we had a really good panel discussion. And please join me in giving a big applause for the panelists. Thank you so much for all your time, and I hope we had a productive panel here, and all the audience were able to basically understand that IoT is something we need to look at. IoT is IoT is a term, but it is actually operating all the many advances that we are going forward. So thank you so much. I also thank all the on-site organizers for giving us the lower session of this conference. Thank you so much.
Thank you.
Thank you. Sure. We can take a group.
A little bit more complex. Let us know.
Small. Ready?
You want to do this slide?
Sure.
Should I move?
Oh.
Is that better, please?
Ready?
Thank you.
Thank
you.
Thank you so much.
Thank you. It was nice.
Thank you so much.
You did a good job. Thank you.
Nice to meet you.
Thank you for all the consideration.
Oh, yeah.
Hey, good job, Ramesh.
Yes. I haven't said that someone has. Okay, thanks.